So here is how we're going to handle this. First, we're going to solve the equation form. So we're given x squared minus x minus 12 is less than 0. If we didn't have 0 on one side, we would need to get 0 on one side. This less than 0 means we want this to be a positive number or a negative number. Less than 0 would be negative numbers. So switch it over to the equation form. So instead of less than 0, write equals 0 and solve it. We want to solve it using factored form. X and x, numbers that multiply to negative 12 and add to negative 1 would be negative 4 and positive 3, which means we get x equals 4 and x equals negative 3. These are going to form intervals on the number line. Make a number line, put your negative 3 on, put your 4 on, and separate the number line. Now, since we have less than but not less than or equal to, these are going to be open circles at negative 3 and 4. If we want this to be less than 0, that means we want x minus 4 times x plus 3 to be less than 0. That's the factored form of the original. In other words, we want this to come out negative. So what I'm going to do is set up a pair of parentheses in each region we created. These parentheses represent this factored form, x minus 4, x plus 3. Now pick a random number from each of these regions. I'm going to stay as close as I can, so I'll pick 5. Ooh, 0 is an option here. I like that. We'll stay as close as we can here, maybe negative 4. So over here, I'm going to plug negative 4 into factored form. Here, negative 4 minus 4 is negative 8. That's going to be negative. Notice I don't care about the number. I just care that in that parentheses, the number would be negative. If I plug negative 4 in here, negative 4 plus 3 is also going to be negative. Negative times negative is positive. We weren't interested in positive numbers. We were interested in negative numbers. So this region is not in our solution set. Let's do it again here, plugging in 0 for x. 0 minus 4 is negative. 0 plus 3 is positive. Negative times positive is negative. So this section is in the solution set. If we put 5 in, 5 minus 4 is positive. 5 plus 3 is positive. Positive times positive is positive. So this section is not in the solution set. So we only shade region 2. We know which direction our parentheses are facing now. In interval notation, our solution is 3 to 4, not including either value. So parenthesis negative 3, comma 4, parenthesis. Let's do this again, same process. We have 2x squared plus 5x minus 12 greater than or equal to 0. Let's do the factoring first. Let's get that out of the way. So there's nothing we could take out. If we use the AC method, or we do a times c, we need numbers that multiply to negative 24, 2 times negative 12. They need to add to positive 5. That's going to be negative 8, no, positive 8, and negative 3, because we need them to add to positive 5. You can use the AC method, make this 2x squared plus 8x minus 3x minus 12, and factor by grouping. Remember, I'm a fan of that new version of factoring I showed you in lesson 11. Since we have a 2x squared, I'm going to put 2x and 2x. I'm going to put in our numbers, plus 8 minus 3. Here we have a common 2 we can divide by, which gives us x plus 4. Nothing in common here, so we leave it 2x minus 3. X plus 4 times 2x minus 3 is greater than or equal to 0. That's the factored form. So we want this to be greater than 0. We're interested in positive numbers this time around. To find our boundaries for our regions, change it to equals, and solve. So x plus 4 equals 0, 2x minus 3 equals 0, x equals negative 4, x equals positive 3/2. So a number line, we'll put on negative 4 and 3/2. Which splits us into 3 regions. Test points, I'll pick 0, I'll pick 2, I'll pick negative 5. Out here I stayed as close as I could. In there, 0 was an option, so I picked it. Parentheses to represent our factored form. That factored form, 2x minus 3 times x plus 4. I switched it back because I like the 2x up front. You can leave it x plus 4 first if you want. Doesn't matter. Remember, we want things to be positive. So last time we had open circles. This time, though, since it's or equal to 0, we have filled in circles at negative 4 and at positive 3/2. If I plug negative 5 in, we get 10, negative 10 minus 3. That's going to be negative. Negative 5 plus 4, that's also negative. Negative times negative is positive. So this region makes it in. You can shade it if you want. Don't think that you know it's going to go no, yes, because of the pattern. I mean, you'd be right in this case, but there are instances where this does not happen. So you can't assume every case is going to switch back and forth. Most of them will. But don't assume that. It's going to make an F out of your grade. Okay, that might have been an over-exaggeration. Plug in 0. 0 minus 3 is negative. 0 plus 4 is positive. That gives us a negative number. We don't include region 2. Plug in 2. 4 minus 3 is positive. 2 plus 4 is positive. Positive times positive is positive. This region's included. Shade it. Now that we know what direction we're going, these are brackets. And this is going to give us interval notation. We have negative infinity to negative 4, including negative 4. We need to combine it with another. We use that union symbol. 3 halves to infinity. If a projectile is launched from a ground level with initial velocity of 96 feet per second, its height s in feet 10 seconds after launching is given by the following equation. S equals negative 16t squared plus 96t. If you take a physics class, you're going to learn how to make these equations. This is not a physics class, so they will always give you this equation. So again, S is our height. T is our time in seconds. Height was in feet. So the question they ask us is, when will the projectile be greater than 80 feet above ground level? So when will we be greater than 80 feet? In other words, when will 80 be less than the rest of this? Gosh, I sure hope that's right. It is. Think of it this way. If you don't want to think of it in terms of less than, this negative 16t squared plus 96t is s. So if we say s greater than 80, s greater than 80. No, that's the same thing. Either way you write it. So let's actually solve this. We're going to factor. Before we can do any factoring, we want to get everything on one side. So subtract 80, 0 on the other. Here, 16 is actually a number we can take out of all of this. In fact, let's take out a negative 16 so that we keep this t squared positive. So if we take out the negative 16, we're left with just t squared. And we would also have minus 6t, 16 times 6 is 96, and plus 5, 16 times 5 is 80. Negative times positive is negative. And now we're going to get rid of this negative 16 by dividing both sides by negative 16. And what happens when we divide by a negative? We reverse the sign. So we have t squared minus 6t plus 5 is less than 0. factor. The numbers that multiply to 5, add to -6, are -1 and -5. This gives us 2 times. T equals 1, T equals 5. Now again, that would be the solution to the equality. Why do we do that? Because we need the number line. And we need to know what to put on the number line. Less than, so open circles at 1 and 5. Splits us into 3 regions. Over here I'm going to use 0. Here I'll use 2. Here I'll use 6. Doesn't matter what you pick as long as it's in the region. It's just a representative point. Now, before I do the testing, since this is a real-world example, let's try to predict what's going to happen. So we're launching something from the ground. How's the old song go? What goes up must come down. So let's say this is the ground, this is 0 feet. We want to know when the projectile is going to be above 80 feet. Well, it's going to hit the ground again eventually. But let's just say this is 80 feet. It's going to go above it for some distance, and then eventually it's going to fall back down below it. If we picture this as our number line, where it's above 80 is going to be between our 1 and our 5-second marks. So let's now mathematically show that we're going to get the section in between. We'll stick with this page. So, factored form. We need our numbers to be negative, less than 0. The factored form represented is t minus 1 times t minus 5. So if we plug in 0, 0 minus 1 is negative, 0 minus 5 is negative. That gives us a positive section, so no there. If we plug in 2, 2 minus 1 is positive, 2 minus 5 is negative. That's a negative section. There we are, shading the middle just like we predicted. If we plug in 6, 6 minus 1 is positive, 6 minus 5 is positive. That's a positive section and a no-go. So as predicted, our interval between 1 and 5 is our answer.
Negative 7u times u plus 2 squared times 5 minus u is greater than 0. We want to solve this inequality. We want to put the solution set in interval notation. Well, it's already in factored form with 0 on the other side. We want this to be greater than 0, which means we're looking for where this is overall positive. Let's imagine we had this equal to 0. Let's find the zeros. Negative 7u equals 0. U plus 2 squared equals 0. 5 minus u equals 0. We get u equals 0. Square root both sides. Subtract 2 from both sides. We get u equals negative 2. Subtract 5 from both sides. Take the opposite of both sides. We get u equals 5. We give ourselves a number line for graphing. Let's put these numbers on there. 0, 5, -2. This has split the number line into 1, 2, 3, 4 sections. In each of these sections, we are represented by 1, 2, 3 factors multiplied together. 1, 2, 3 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 multiplied together. The first one represents the -7u. The second one represents u plus 2 squared. The third one represents 5 minus u. We want to see where this works out to be positive. So we want to do a sign check. On what? We're not plugging in -2, 0, and 5. That's going to give us 0 everywhere. That's what it means to be a 0. When you plug it in, you get 0. We need test points. So I need to pick a representative from each of the 4 sections. We're playing Hunger Games. 6 volunteers for tribute. 1 volunteers for tribute. -1 volunteers for tribute, and -3 is forced into tribute. Very sad. Let's put -3 into -7u. -7 times -3 is positive. That's all we care about. -3 plus 2 is -1. -1 squared is positive. In fact, anything squared is going to end up positive, which means that the middle factor in all of these is going to be plus. No matter what we plug in for u, when we add 2 and square it, it's going to be positive. Back to -3 though. -3 plugged in here. 5 minus -3 is 5 plus 3, which is positive. Let's move over to -1. -7 times -1 is positive. Five minus -1 is 5 plus 1 is positive. Let's go to +1. -7 times +1 is negative. 5 minus +1, that's positive. And over here, 6 is playing now. -7 times 6 is negative. 5 minus 6 is negative. Okay, so what was the point of that? Well, positive times positive times positive is overall positive, which is what we want. That section gets included. Positive times positive times positive is overall positive. That's what we want. This section is included. Over here, negative times positive is negative, times positive is negative. Overall negative, that's not what we want. That section is not included. Negative times positive is negative, times negative is overall positive. Section 4 is included. Now, remember what I said, when we plug -2 in, when we plug 0 in, when we plug 5 in, we get 0. That's not positive, that's not negative. We don't want greater than or equal to 0, we just want positive, greater than 0. Which means section 1 is included. Section 2 is included. But that number in between section 1 and section 2, that -2, That is not included. Section 3 is not included, but section 4 is. We do not include the 5 because we do not have greater than or equal to. We just have greater than. So now we have to write this in interval notation. Interval notation to represent sections 1, 2, and 4. Section 1 is negative infinity to -2, -2 not included. We're unioning that with section 2. -2 to 0, neither included. And we're unioning that with section 4. Don't accidentally put 6. The barrier is at 5. 6 was our test point. Section 4 goes from 5 to infinity. So that is the answer to the inequality. Negative infinity to -2, union -2 to 0, union 5 to infinity.
Five over x plus 4 is greater than or equal to 1. So a rational inequality looks like it has a rational expression inside of it. Again, we want to get everything on one side, 0 on the other, just so we can see greater than 0, less than 0. This could be a pain. Because when we subtract 1, we get 5 over x plus 4 minus 1 greater than or equal to 0. We need to get a common denominator. 5 over x plus 4, this would be minus x plus 4 over itself. A nice convenient form of the number 1. So this is 5 minus the entire x plus 4, so put it in parentheses, all over x plus 4 greater than 0. Because what we want is a rational expression on one side and 0 on the other. So 5 minus x minus 4 . 5 minus 4 is 1. So 1 minus x over x plus 4 greater than 0. That means we want this thing to be positive. We're going to make a number line just like last time, but depending on where we, well, first of all, where are we going to get the numbers from? We're going to take the top, set it equal to 0. We're going to take the bottom, set it equal to 0. So x is going to equal -4. Negative x is -1, x equals 1. So x equals 1, we got that number from the top. The numbers we get from the top are going to be bound by the inequality sign. Greater than, not greater than or equal to. Oh, I'm sorry, this was greater than or equal to the whole time. So let's go ahead and put those back in. Which is good, we won't need another example. Since x equals 1 came from the top, and since this was greater than or equal to, 1 is going to have a filled in circle that'll eventually become a bracket. X plus 4, that was the bottom. Bottoms of fractions cannot equal 0, which means x cannot equal -4. So even though we have the greater than or equal to sign, because -4 is a number that makes the bottom 0 and therefore makes the rational expression undefined, we have to have an open circle at -4. again, this is 1 minus x over x plus 4. We want it to be greater than or equal to 0. We want positive results. Our regions, just like the quadratic. Our test points, just like the quadratic. But instead of a pair of parentheses, set up a fraction. One thing over one thing. The top represents 1 minus x. The bottom represents x plus 4. So if we take negative 5, 1 minus negative 5 is 1 plus 5, which is 6, which is positive. Negative 5 plus 4 is negative. Positive over negative is negative. We don't want that section. If we plug 0 in, 1 minus 0 is positive. 0 plus 4 is positive. That is overall positive, which is what we want. If we plug 2 in, 1 minus 2 is negative. 2 plus 4 is positive. This is overall negative. We don't want it. Open circle becomes a parenthesis. We shade inside here region 2, so the parenthesis faces in. Closed circle is a bracket. So we have a parenthesis with negative 4 and a positive 1 with a bracket. Okay, one more example, then we are done with this lesson. In example 9, again, we have a rational inequality, 2x minus 1 over 3x plus 4. We have this less than 5. We need everything on one side in a single rational expression, 0 on the other. So we're subtracting 5. It's less than 0 now. We need a common denominator. That's going to be our 3x plus 4. We already had a 5 up here, but we're going to need another 3x plus 4. First one's not going to change. All over 3x plus 4. We have 2x minus 1 minus 5 times 3x plus 4. Distribute. So 2x minus 1. Negative 5 times 3x is negative 15x. Negative 5 times positive 4 gives us minus 20. I didn't make a mistake. You made a mistake. All over 3x plus 4. Simplify up top. 2x minus 15x is negative 13x. Negative 1 minus 20 is negative 21. All over 3x plus 4 is less than 0. Yes, this is what this problem is supposed to look like. There are not any mistakes. If we take the top, set it equal to 0. Get negative 13x equals 21. X equals 21 over negative 13. And if we set 3x plus 4 not equal to 0, because it's from the bottom, always going to be an open circle. 3x can't be equal to negative 4. X can't be equal to negative 4/3. So our number line, this was a less than, not a less than or equal to, so everything is open circle. So negative 4/3 is negative 1.3. Negative 21/13, so it's going to be closer to 2 than it is to 1, the negative side. So negative 21/13 is to the left of negative 4/3. Open circle, open circle. I'm going to use negative 1. I'm going to use 0. 0's off in that region. Here we would need a number between negative 1.3 and, let me do a calculator on this real quick. (21 divided by 13 is 1.6. So between negative 1.3 and negative 1.6, I'm going to pick negative 1.5. Over here, I'll pick negative 2. We have our 3 regions. Our fraction is going to be negative 13x minus 21 over 3x plus 4, less than 0, so we want it to be negative. So set up one thing over one thing. In your homework, you might get problems where we have a factored form on top and a single thing on the bottom. So you might have 2 on the top, 1 on the bottom. I just call this a sign check because we're checking signs. If we put negative 2 in, it's negative 26 minus 20, put in negative 2, we get positive 26. Minus 21 is positive on top. The bottom, negative 6 plus 4 is going to be negative. So that's overall negative. It's what we want. So that section is shaded. Always shade in the arrow as well. Negative 1.5 times 13. I'm going to go back to the calculator. Negative times negative is positive. 13 times 1.5 is 19.5. Minus 21 is negative. Three times 1.5 is going to be negative 4.5 plus 4, still negative. Negative over negative is positive. We don't want that section. If we put in 0, 0 minus 21 is negative. 0 plus 4 is positive. Overall negative, it makes it in. So our answer in interval notation, negative infinity to negative 21/13. Union, because we're joining it with another interval. Negative 4/3 to infinity. We have x minus 7 over x plus 8 is less than or equal to 0. We have a fraction on one side, 0 on the other, so we're able to get some key numbers. A 7 from the top and a negative 8 from the bottom. Setting them equal to 0 gives us positive 7 and negative 8. Let's put that on a number line, negative 8, positive 7. The negative 8, since it comes from the bottom, is going to be an open circle. It doesn't matter that we have the or equal to here. We can never be equal to negative 8 because negative 8 plus 8 is 0. We cannot have 0 on the bottom no matter what. So since we can never have x equals -8, that's open. But the positive 7 is going to be a filled in circle because the rest of the problem has this less than or equal to. So we have 3 regions. And this is set up as a fraction, x minus 7 over x plus 8. Let's pick some test values, -9, 0, and 8. And plug it in. -9 minus 7 is negative. -9 plus 8 is negative. Negative over negative is positive. Putting in 0, subtracting 7 is negative, adding 8 is positive. This region's negative. Plugging in 8, 8 minus 7 is positive, 8 plus 8 is positive. This region is positive. We wanted less than 0, that means negative. So we're shading in the negative region, giving us an answer of interval -8 to 7, not including -8, but yes, including 7. Let's take a look at 1 over m minus 2. And we have this greater than or equal to 2. I'm going to go ahead and subtract 2 from both sides. Why? Because I need it equal, or in this case, greater than or equal to. I need 0 on the other side. Not only do I need 0 on the other side, though, I need a single fraction across from it. So I need a common denominator. That common denominator is going to be m minus 2. So I do m minus 2 over m minus 2. Because that's 1. 2 times 1 is just 2. That's how we find common denominators for fractions. See, if you know how to work with the fraction, you know how to do this. It's the same reason that 2 would be equal to 6 over 3. Because 2 times 3 over 3 is 2 over 1 times 3 over 3, which is 6 over 3. You can do it with numbers. You can do it with rationals, with the functions. So if I want to rewrite this, I have 1 minus 2 times m minus 2 all over m minus 2 greater than or equal to 0. I just subtracted 2 fractions with a common denominator, that's all. Simplifying the top, distribute that 2, distribute the -2. 1 minus 2m, -2 times -2 is plus 4. All over m minus 2, almost done simplifying. 1 plus 4 is 5. 5 minus 2m over m minus 2, greater than or equal to 0. So that's the first part of solving a rational inequality. Got to get 0 on one side by moving everything to the other, and then that other has to get simplified into one single fraction. But then everything past this is very familiar. 5 minus 2m over m minus 2 greater than or equal to 0 means we need this to be
overall positive. The zero of the top, 5 minus 2m equals 0. Subtract 5 from both sides. Negative 2m equals negative 5. Divide both sides by negative 2. M equals positive 5 halves. Just like the regular polynomial inequality. Find the zeros. Here we also need the zero of the bottom. M minus 2 equals 0. Add 2 to both sides, that's m equals 2, but it's on the bottom of a fraction. That means that even though we have or equal to, and this 5 halves will work because it'll give us equal to 0, we can never have m equals 2 because m equals 2 causes 0 in the denominator, which is bad. So we'll make a note that that's something that can't happen. M can't be 2. But these are the two numbers we will put on our number line. 5 halves is 2.5, so 2 would come to the left of 5 halves. This divides our number line into 3 sections, each one represented by a numerator over a denominator of 1 factor apiece. Now, this is the point where we pick our representatives. Where representative numbers from each section would volunteer for tribute. And we can pick something to the left of 2, no problem. We can pick 1. We can pick something to the right of 5 halves, like 3, no problem. What about something between 2 and 5 halves? That would have to be something between 4 halves and 5 halves. And uh-oh, we don't have a number between 4 and 5. So let's boost the denominator. 4 halves would be 8 fourths. 5 halves would be 10 fourths. What's in between? 9 fourths. So we can pick 9 fourths. Another thing you might consider, if this is 2, I know I said stay away from decimals, but maybe it'll be easier for you. This is 2.5. In the middle, you can pick anything. You can pick 2.1, 2.2, 2.3, 2.4. I picked 9 fourths, which happens to be 2.25. When I plug 1 in, 5 minus 2 times 1 is 5 minus 2 is 3 is positive. When I put 1 in, 1 minus 2 is negative 1. That's negative. Let's go ahead and plug in the 9 fourths. And you know what? I cave. Let's use 2.1. I want to make this as easy as possible for you. Rules are meant to be broken. 5 minus 2 times 2.1. 2 times 2.1 would be 4.2. 5 minus 4.2 would be positive, and that's all we care about. 2.1 minus 2 would be positive, and that's all we care about. Decimals to the rescue. If I plug 3 in, 5 minus 2 times 3. It's 5 minus 6, that's -1, that's negative. If I put 3 in, 3 minus 2 is 1, that's positive. So positive over negative is overall negative. Positive over positive is overall positive. Negative over positive is overall negative. We want positive. That's going to be section 2. The 5/2 will work for us. The 2 will never work for us. So the 2 can never be included. But the 5/2 is included. So that's how we have to shade it. So our answer in interval notation is 2 to 5/2, parenthesis on 2, bracket on 5/2.